system. You know that your hydraulic braking system. This is what your hydraulic brake B. Okay, the wheel which presses the brake pedal against the brake shoe against the brake drum. This is hydraulic. Okay, so it requires hydraulic fluid. So the fluid is pressurized. Okay, now there are, you can see that there are two valves. One is called A, which is called inlet valve. Then C is outlet valve. Then you have B is the brake cylinder where the pressure fluid is applied against this one. Then you have an accumulator D. This is accumulator. The accumulator is always used for storing some pressurized fluid and avoid pulsatile flow. Correct? When you apply, open and close the valve, there is a pressure pulsar that should be absorbed. Correct? For that only they put an accumulator which smoothens. It looks like a filter. Then you have a pump motor. Correct? There's a pump motor. Okay. This is a pump. Correct? Then you have damping chamber. Correct? Damping chamber is there. This is the damping chamber. Finally, the pressurized fluid goes and is stored in the master cylinder. Okay. Now, here you can see that when the driver presses the brake pedal, right, the brake booster start controlling the hydraulic modulator, which in turn gets signal from the control unit. Okay. Now, this we are talking about one wheel. I told you here in ABS uses braking control in individual wheels. Okay. Now, in anti-lock brake system prevents wheel slipping. Already we talked in the previous class. Correct? The locking up is nothing but the wheel is not rotating, ceasing the rotation, but it should be prevented. Already told you, if the wheel gets locked, vehicle will skid and use directional control during hard braking. So a system which allows wheel to always rotate till the vehicle comes to rest. That means vehicle body. Till then, the wheel should be allowed to rotate. Correct? So from maximum speed, minimum speed, again release. The rotating wheel allows driver to have the directional control, steerability. I told you, then only you can avoid something. In your lane, somebody is there in front of 50 meters, you apply the brake pedal, right? So your vehicle is coming down speed, but still you are not able to avoid because it's so close. One way is you can take this one. From here you are coming. This is your obstacle. You came here. You see that you still vehicle has not stopped. You can steer and go. Turn your vehicle like this. You can go. So you need a steering control. If the wheel is locked, the steering control, that is one of the major drawback of locked wheel. So your wheel should be always rolling, rotating, at least a minimum speed. Then only you can steer your vehicle so that you can avoid in the emergency case. If it stops, it's well and good. If it doesn't stop, you do that. Then next thing is we talk about traction. Traction refers to maximum frictional force that can be produced between the two surfaces without slipping. What is one? Wheel surface and ground surface. Correct here. Then ABS offers improved vehicle control and decreases stopping distance on dry and even slippery roads also. Because the ABS control individual wheels. As I told, it controls individual wheels. Braking applied individual wheel by applying braking force individually. How much force to be applied? Whether the wheel is locked, all this thing is measured by ABS using a wheel speed sensor. Okay. Suppose when the driver applies the braking force, brake pedal, automatically ECU generate two control signal. One control signal to valve A, that is called inlet valve. Other one is called as outlet valve. These two valves are controlled. I will show in the next slide for easy understanding. I will just tell quickly. Okay, when the inlet A is open, this is open. Correct? This control signal is, I say the 12 volt is applied. The ECU generates the control signal. Correct? So the ECU, this is the control unit. Correct? Control unit generates control signal and applies to the modulator. Modulator in turns gives the pressurized fluid. So this is what the A, right? So the A valve is closed. So from the high pressure fluid will go from here and goes to the wheel. Correct? Now the wheel brake cylinder, high pressure, because the valve is open. During the time, this valve is closed. This is closed. This is on or open. This is open. So that means during the time, valve C is closed. That means low signal. This 0 volts means valve is closed. This is open. Now, since high pressure is applied, the brake shoe presses again wheel. Wheel was rotating. I told you wheel is rotating 100 rotations. Correct? For example, and it brings some 90, 80 like that. When it comes to, for example, 20 rotation, correct? So the ECU is measuring. Please know that wheel speed is measured using individually. So when the wheel speed comes, what the ECU will do is it will bring 0 volts to the valve A. This is valve C, correct? This will become high. Correct? The valve C is open. That means what happens is now there's no further high pressure fluid is coming. This valve is closed. Right? So, but already a high pressure fluid is sitting is in this pipeline. Right? This pipeline is have up to this one. That's why there's a pressure is there. The pressurized fluid is there. Let me clear this. You will see it. The pressurized fluid is there in this part. Even though this valve is closed, because the valve is closed, this is closed. This is open. I'm talking A valve. And when A valve was this one, C valve was closed. And after some time, when the wheel speed come to say 20 RPM, the ECU changes, it sends a control signal. So this valve is closed because it becomes 0 volts, but C valve, outlet valve is open. So what happens, the pressurized fluid in this section will go to the pump. Pump is always running. It sucks the fuel and pressurizes again, goes and stores in the master cylinder. Correct? This is one cycle. This is one cycle. Correct? So during this time, for example, wheel was rotating, for example, 100 rotations. By this time, because the wheel is pressed, the speed has come to 20 RPM. Okay. Now, again, this valve is closed. This is closed, automatically pressure reduces. Correct? So that means during this time, pressure reduces. So what will happen? The brake shoes comes out. The wheels start increasing. During this period, again, wheels start with 30, 40, 50. Where it will go? It will not go to 100 because engine is not running. Some amount of energy in the vehicle body is removed by brake shoe. So it may go to 80 RPM. Okay. Next time again pressure is applied. After some time. That time this valve is closed. This is open means C is closed. That time brake is applied. Again from 80 RPM it becomes 60, 40, 20. When it comes 20, what will ECU is monitoring the speed. I'm talking individually, same thing upon all the 4 wheels. So ECU will again open the outlet valve, it will close the inlet valve. Pressure is reduced. Now by this time, the speed of the wheel will come to 60. Now again it applies force. So this is called modulation. Applying braking force by opening this valve A. At that time, this valve will be closed. This open means C will be closed. Then only brake pressure will apply. When after some time, when wheel speed comes to a known value, ECU closes this valve and opens this valve. So the pressure goes, brake is relieved. So this is called as brake modulation. Okay, you understood? Okay. Now, while braking is happening, correct? First thing you understood traction. Another word is called tractive effort. The force available at the contact between the drive wheels and the road is known as tractive force. Correct? In case of, we know that most of the vehicle, correct? The driven drive wheel is back wheels, correct? From your engine, gearbox, propellers are differential, back wheel is driven, where 2 wheels are driven, correct? So,
Professor sir, I'm sorry, sorry to interrupt. One question, sir. This ABS will come into play in operation only at the incident when the wheel lock is being sensed, right? In a normal braking system.
Braking. If you have ABS system, if your vehicle has ABS, the braking itself is controlled by ABS system only.
Okay.
Okay. So what you do, you're pressing here, brake pedal, right? Brake pedal is pressed by driver. Okay. There's no mechanical link.
What I meant was, sir, if the wheel is not locked, then the modulation between A and C valve will not be happening, right? Is that?
Yeah.
Is that?
No. If you apply brake pedal, the A will open.
Okay.
Brake shoe is pressed because you want to stop the vehicle, no?
Exactly.
At the t equal to 0, I say that t equals 0. You are pressing this is t equals 0. You press the brake pedal. Immediately valve A will open. During that time, valve C will be closed.
So modulation will not since the wheel is stopped, or is
The modulation happens. Once you press the brake pedal, modulation starts.
Oh, okay.
You want to stop the vehicle, no? See, when vehicle is moving, the pressure will be 0. This C valve will be open. This will be closed. When vehicle normal condition, when you are not pressed the brake pedal. Correct? When brake pedal is not pressed, the brake shoe is removed. It is not pressing. So that means the high pressure fluid will not be there. That time the C valve will be open. So high pressure will come, the pump, and it comes and stored here. High pressure fluid is not there in this section at all. So there's no braking force. Your wheel is rotating and accelerating, all those things. Once you press the brake pedal, driver pedal, then you want to stop this one. Immediately, the C valve will be closed. First thing, C valve will be closed. Then A valve will be open. That's what happened. A valve is open. So the pressurized fluid comes and apply braking force for this amount of time.
Got it, sir. Thank you.
Okay. Now, at this time, please note, at this instant, because at this time, this will rotate 100 RPM, you apply braking force, for example, 10 millisecond, correct? The rotation from 100 rotation come to 20 rotation, for example, will not come that much. Or understanding why saying it will come only few rotations. 100 it have reduced to say 80, 90, something like that. Correct? So it releases. Correct? So for understanding why I said now, for this duration, this valve is open. That means pressure is released. C valve open, A is closed. All the fluid pressure in this duration, it will be released. So no braking forces. Again, after 20 milliseconds, again brake force is applied. How? This C valve is closed, A valve is open. So the high pressure fluid comes, again brake is applied. This happens till vehicle speed comes to 0. So that is called a modulating, opening and closing, opening and closing. You can see that both are, this is A valve, this is C valve. This happens till, for example, say 2 minutes or 30 seconds, till the vehicle comes to stop. Right? Wheel speed, vehicle speed, not wheel speed. Body is moving because of the inertial force. Already you are accelerating 80 km speed. Till that energy is dissipated, the body will push. If the once the brake is the brake force is applied, what will happen? Body will push your wheel. Wheel will start rotating because it has energy. When the body energy becomes 0, then body will not push because engine power is already you are not accelerating. You are cut off your engine while applying brake.
Sir,
yeah. Yes.
For our understanding, can we plot vehicle speed against time when we apply the brake?
Vehicle speed was going 70 kilometers at t equal to 0. Vehicle speed was under this one.
Yes.
Okay. Now vehicle speed will reduce like this.
Right.
Theoretically you want like this, but generally it will not be like this. It will be slightly like this. Correct? At circular time, the vehicle speed from 70 it come to 0. Vehicle is stopped. It should come to 0. Literally speaking.
Clear, sir. Yes.
This time may be 20 seconds, 30 seconds. What is current speed? Correct? Slipping should not happen. Vehicle speed and also road surface. If it is wet surface, dry surface, concrete, all those things decides up to what time brake will be there, at what distance, stopping distance. Every time when pulse goes, this is the brake on. Correct? You can see that original this one it has reduced. Again it is reduced. Correct? During this you are applying brake. So that automatic speed vehicle reduces.
Yes, sir. Thank you.
Okay. Next thing I wanted to tell you what you call a tractive effort. tractive is the force available between the wheel tire surface which is touching the road. You call it tire patch, you call it, correct? Under the road, correct? The force between the drive wheel. Drive wheel means where the actually engine is connected through its gearbox and differential. Front wheel is not drive wheel, correct? It is a driven wheel. Correct? Front wheel is driven, back wheel only you are driving. But that effort, correct? The force available on the between a tire and the road surface is called as force available, correct? Tractive effort, that is called tractive effort. Then next thing is the ability of the drive wheel to transmit this effort without slipping is known as traction. Correct? The tractive effort, because of tractive effort, there's a traction. Correct? If you say traction is there, wheel is not slipping. It is rolling, but there's a contact. There's a friction is there. Correct? So we say that if you stand in vehicle, you said your traction is lost. That's why you say, no, technically you say traction lost because wheel is slipping. Correct? So that is called the traction. Hence, usable tractive effort never exceeds traction. Correct? So when the tractive effort F is greater than R, okay, that is total resistance road surface, the surplus tractive effort is used for accelerating your vehicle. Correct? Tractive force should be greater than the resistance. What is the resistance? The friction between road surface and tire. That is primary. Correct? The next thing is your drag force also. Not only this one, vehicle drag force. Correct? Any other forces which is opposing the forward motion of your vehicle is called as R. That if you add all the forces, correct? I say that F tire, correct? Ft plus F drag force, aerodynamic drag, plus any other forces working against the forward motion. Combinedly, we call this R. Add these forces. Then the F is nothing but the force generated by the engine. Correct? The force generated by engine is greater than this resisting force, the combined forces. Then only the vehicle can accelerate. Correct? So now the tractive effort can be related to engine power using the following formula. Note down this formula. In the exam, you can expect simple problems. If engine is there, this one, what is tractive force? Then this is resistance. Simple to understand. If you do a problem in the exam, then you remember formula, you will understand subject more. Correct? So take these equations. The engine torque, we know that the engine torque developed by engine is nothing 60,000 PE divided by 2 pi n, where PE is the engine power. I say that the 60 kilowatt engine, 100 kilowatt engine, that is engine power is in the numerator. 60,000 is a constant. 2 is a constant, pi is called 3.14. You know that n is the engine speed, where n is called as engine speed or crankshaft speed. Correct? Now, this is the torque engine torque. This is TE, torque generator, subscript E says engine torque. Now, torque at the drive wheels. Engine producers, you have your engine, correct? Engine is connected to gearbox, GB, correct? After that, it is connected to your propeller shaft. Then you have differential drive, correct? DG, differential drive. That is another one gear. Then finally, it goes to wheel. These are the two wheels. I am talking drive wheels, back wheel. Now, here I am getting TE. After that, this is given as input to gearbox. Then gearbox may amplify this. This is a TB, correct? TB can be greater than or less than TE, depending on gear ratio, right? Gearbox can amplify the engine torque. Torque for the engine is fixed. That depends upon the power of the engine. What is current RPM? That correct? So this gearbox can amplify torque. If you put a first gear, the engine torque is amplified. Then TB will be greater than TE. Engine generate 10 Newton meter. Your gear ratio 10 means 100 Newton meter will be the gearbox output. Because in first gear, you want to amplify maybe 3 times, 4 times, because engine at initial this one, your engine torque is low. You know the torque is like this. Speed versus torque, engine torque, correct? So it has a peak torque at one particular RPM only. This is 0 RPM. This is, I say that 5 or 6,000 RPM for engine, correct? So this may be 4,000 RPM. 4,000 RPM and the peak torque producer. But now when you are accelerating initially, correct, you are here somewhere. The torque may be less. This torque may be 100 Newton meter. This may be 30 Newton meter. That is not sufficient to move your vehicle forward. Correct? In fact, vehicle speed at 0 means 0. That's what I say. Electric vehicle, that is advantage. Electric motor. Electric motor starting torque is a maximum torque. It is a flat curve. Electric motor outperforms any IC engine in the torque speed versus torque curve. Electric vehicle can accelerate with the maximum acceleration 0 speed. Right? At 0 speed, engine torque is 0. That's why you have the gearbox to amplify. When low throttle or low engine speed, the torque for the engine is less. But that is not some. But you need maximum torque when the vehicle is at red condition. You started engine, tires are not moving. Correct? This one, friction. Correct? And the normal force acting on individual tire is maximum because wheel is not rotated. That time only you need maximum static friction, all those things. That time you need maximum, but that time only your engine gives less torque. So that's why you have the gearbox. Correct? So you give this one, I amplify 3 times, 4 times, you want to put the first gear. But of course, the wheel will be running at the 3,000 RPM. After gearbox, that will be reduced 4 times. Correct? It will become 750 RPM. But torque is amplified. From 30, it becomes 120. So your vehicle can start moving. You need maximum torque when to start move the vehicle from rest condition. Correct? Once the wheel start rotating, the static torque is gone. So only aerodynamic torque and this one is there. Fine. Now coming back to torque, this is engine torque. How much will be available at the tire? Correct? Wheel. Correct? That is nothing but gearbox ratio GR multiplied by AR multiplied by eta T. This is eta T is not efficiency. Everything is here. Then TE. What is the TE? Already we know that engine torque. Eta T is not the transmission efficiency. Correct? Gearbox also efficient, cannot transfer because of frictional losses. Correct? All those things are there. If in the gearbox I have input, I give 10 Newton meter torque. Correct? And I have a gear. Both are same size. Correct? Gear, I say GR equal to 1. Correct? Theoretically, you should get same. This is my load. Correct? This is my engine. Engine gave 10 Newton meter. Gear ratio is 1. Load should, how much it should get? It should get same 10 Newton meter. Will you get? Never. Because frictional losses. So you will get maybe 9.5, 9.7, depending on how good your gear is, how less is your friction in the gear. Correct? Two surfaces are touching and so, but I want 10 is same amount, but it won't come. That is called gear efficiency. Suppose I get a 9 Newton meter. What is my efficiency? Output by input multiplied by 100. Correct? Is the gear, that is what eta T. Transmission system efficiency. Here gearbox we are talking. Correct? So here there are efficiency. Then here GR and AR. What are GR? Gearbox ratio and axle ratio. Okay. Now this equation can be reduced to, again you can rewrite as capital G into eta T into TE. Correct? What is capital T? Is this. These two factors can be combined. Right? Gearbox ratio and axle ratio. Okay, if you multiply it together, that is given as capital G. Okay, so you can write the torque at the driven wheel is G into eta times T, engine torque. Okay, then what is your tractive effort available? Correct? This is torque available wheel. Tractive effort F equal to, tractive is a force. F equal to this T divided by TW. This is correct. torque available at wheel divided by R. Okay. What is R? R is the radius of the tire. Radius tire. Now we know that TW already have this value. So if you substitute this value here, you will get this. Okay. So the tractive force, tractive effort available for moving your vehicle forward, accelerating is so many Newton. Correct? It is a linear force, so it is the unit is Newton. Okay. So we know that G is the overall gear ratio, drive ratio is a product of your transmission gear ratio and gear at the differential drives. That is what is here it is told as axle ratio. Differential gear also has, does a gear. Differential also is a gearbox, no. It also has a gear ratio. That means gearbox ratio multiplied that is capital G. Once that is known, then you can find out what is tractive effort. For a given system, if engine power is given, engine speed is given, then you can find out what is TE. Correct? Engine power is given, what is engine RPM current is given. Then I gave GR and AR, gear ratio, gearbox ratio, what is current gear ratio? I say that 3:1. This is say 1.5:1. Something like that. I give the number. Then you can calculate, multiply these two, you will get capital G. Correct? The capital G multiplied by eta T. Eta T is given. Overall efficiency. I say overall efficiency 90%. Correct? That means 0.9. Efficiency nothing but you should take as 0.9. Efficiency we can vary from 0 to 1 normally, but we always tell efficiency in percentage, then you multiply by 100. Correct? You will multiply by 100. So generally I give efficiency as a 0.85. Eta T equal to 0.85. That is given. Gear ratio, GR is given, AR is given, engine power is given, engine speed is given. Correct? Then tire radius is given. Tire, I say that 0.5 meter or 0.3 meter is given. Then you are asked to find out what is the tractive force. At every RPM, at every power, for a given vehicle, gear ratio is, for a given gear ratio, correct? This will vary, correct? GR will vary. You will be in first gear, second gear, third gear, fourth gear. But this will not change. AR generally remain constant. Differential, only one gear is fixed, correct? Now, if I given the gear ratio, this one, and for particular gear ratio, I am in the first gear. Gear ratio is 3:1 or 4:1. I say my engine is 2000 RPM. The power developed by engine is say 50 kilowatts. Right? Tire radius 0.5 meter. Find out the tractive force F. Right? So this is how you calculate. Since we are talking about this. Now, coming back here, I wanted to talk basics on braking system. We are talking ABS. Correct? Because ABS, I talked about tractive effort because this is part of the braking also. Correct? Tractive efforts is used for driving the vehicle. If tractive effort is not there, vehicle will not move. Correct? So now, when we talk about ABS, we need to understand few key words and key phrases. Braking. One is called wheel slip. Wheel slip is nothing but what is the current vehicle speed and the wheel speed. Please note that vehicle speed and vehicle body speed. Body is moving in linear. This one, correct? Wheel is rotating. Wheel speed and vehicle speed should be known. Okay. Then the difference between these is called a wheel slip. Then next one is the optimal braking performance achieved when this wheel slip is 10 to 15%. Maximum maybe sometimes even 5 to 20% they say. Generally they say 10 to 15 is best. But many times the ABS is used to maintain the wheel slip from 5 to 20%. That time only the best braking force applied. That means vehicle can be reduced. Vehicle speed can be reduced to as quickly as possible to 0 speed without slip, without wheel getting locked and vehicle wheel getting this one skidding. So you need to maintain. The ABS job is to maintain the wheel slip between 10, generally you can take this number. I will show the graph, you will see that here itself is there, correct? You can see here tire slip, correct? That is called a wheel slip. Wheel slip or tire slip, both are same. Tire slip is varied from 0 to 10%. Correct? Tire slip is 0 if there is no braking. If wheel is touching the road, correct, and rolling, not slipping. Wheel is not slipping, it is rolling, correct? You are not applying any braking force. Now, if wheel gets stopped, then we say wheel slip is 10%. Right? Wheel per. This graph is a very good graph. You can see that. That is x-axis is wheel slip. This one we are talking about tire slip. Y-axis is they are giving two graphs. One is in blue color. Other one is called as the braking force. Correct? It is in the brown color. Okay. Then we are also seeing another thing for the blue color. There are different graphs. One, correct? One is for dry concrete road. Other one is for dry asphalt or tar road. In India we say tar, right? The asphalt is we say colloquial tar. Then wet asphalt. That means asphalt road with water, maybe rain. Rain has water is there, not floating. Some thin layer of water is there, some layer, a wet road. Then road is covered with snow. Loose snow, correct? So snow is a loose particles. Then road is covered with ice. That means you know the ice water hardened. If snow particles are compacted, it becomes ice. Correct? It will be a transparent. It will be very hard. Correct? Thick. So ice. Now we are talking about the braking when vehicle is moving, depending upon tire slip. That means vehicle speed when wheel slip. The you can see that lateral force, which is a cornering force, other is a braking force. Okay, it is varying. You can see the curves are going like this, blue color, right? So, okay, now we are talking about the braking force, correct? The braking force will be good only this region. You can see the peak value. Okay, that means if wheel get locked, the braking force becomes 0. Correct? Wheel get when skidding happens. Correct? The vehicle does because it is sliding over the road surface. Okay, so we know that optimal braking performance is achieved when wheel slip. That is in this region. Here you can see that 10% to 15%, but generally you can see up to little high also. Correct? Depends upon. Okay. So then during the wheel lockup, the slip becomes 10%. That means wheel is not rotating, vehicle is moving forward. Correct? Vehicle speed is there, wheel is locked. This becomes 0. So it becomes 10%. This is what. Correct? That time your vehicle starts skidding. Lock wheel does not provide lateral control. Correct? This is called lateral control. Correct? Cornering forces that also become less. Correct? You can see that they become 0. These curves, the brown curves are the lateral force. When wheel is without brake, when wheel is rotating, you can say maximum lateral force. That means you can steer the vehicle, turn wheel left to right. But as the slip become more and more, you see that they are falling. Correct? They are falling. When wheel is locked, correct? You cannot turn your wheel. Lateral control becomes 0. That means you cannot turn your vehicle. You cannot avoid the obstacle in front of it if wheel is get locked. That is why we say that wheel should not be locked. When wheel gets locked, what do we have? Two things happens. What are things happens? The braking force also is less. For this is the peak. Correct? For dry concrete, peak braking force is available when slip is this much, 30% slip. Correct? For the dry asphalt road, the peak braking force is available when slip is around 40%. You can see this is the peak braking force. Correct? Similarly, for wet asphalt, this is the peak. It happens something around 20% when wheel slip is. Same thing if it is a wet asphalt, you can see that it comes. Then snow means you can see that snow surface. You get this one, right? Here is no use. Both are very bad. Snow and ice. You can see that the braking force is very, very less compared to this. Correct? The braking force is very, very low. Right? So you have to be very careful when you are driving your vehicle in the icy or snow surface. Okay. That anyway, in all for this one, we see that they are coming down. Correct? At this one, they are always coming down. So if rear wheel is locked, the wheel will spin. Another thing. Back wheel is get locked, wheel will spin in same location. That is also another problem. Okay. So vehicle moving, tire is not rotating. Correct. Then 10% slip. Correct. Vehicle tire is rotating. Okay. 0% slip. That means this is not good. This condition. Okay. Now already we know about anti-lag, how it works.
Professor,
Sir, one question.
Yeah. Yes, please.
Sir, in the previous graph,
Okay.
even though braking force is varying from 0 to this 100% blue line, at some point of time the braking force is maximum, sir. So what does it specify? Like
that is that is during the condition the wheel slip. This is for this. This is the wheel slip allowed. If the road condition is dry concrete, correct, for most of the tire, correct, the maximum braking force will be available when wheel slip is 30%.
okay, sir. So optimal brake performance will happen at
30% slip. If the ABS maintain 30% wheel slip, then the braking force will be maximum. Stopping this will be best if your road is a dry concrete.
Understood, sir. So it will differ for road to road. Okay.
Road to road. Okay. So this already we talked. I'm not going to explain. Wheel speed sensor needs because you have to measure individual wheel speed so that it does not get locked. When you apply braking force, the wheel speed will start reducing. Then it should be stopped. That's why individual brakes are there.
Sir, I'm sorry. I have a question for the previous slide only.
Okay.
Sir, if the suppose if you take an example of tar road, like what I mean to say is black road where the
asphalt road. That is asphalt road.
Yes, sir. So that is basically where the friction between tire and the road will be maximum that way.
That will be maximum when slip is around 40%. That's what they say.
But my question is that, sir, on that road where the like acceleration of the vehicle is limited by traction control, why there will be slip of the wheel? What I mean to say is, if the mu into R, which is R is the normal action given by the vehicle load, vehicle weight, and mu is your friction coefficient between tire and thing. So if the traction force is more than mu into R, then only wheel will slip, right, sir?
Traction force
is more than mu R, then only the acceleration will happen. Or what I mean is skidding will happen. But whether that is the case, sir, that's the question is.
See, if this force is lesser than the R, vehicle will not move. Now you want to stop the vehicle.
No,
you are
not
trying
R,
to
sir.
balance. You are trying to balance now.
I'm sorry, sir. What I mean to say is, sir, between the tire and the road,
okay,
the acceleration which will be like wheel will get rotated because of mu into R. R is normal reaction given by the low weight of the vehicle, not the resistance.
Yeah.
So in the tar road or the concrete road where the mu is maximum and normal acceleration of 100 kg is there, so mu into n is the total available force, available trajectory effort of the wheel, where the wheel will not slip. So if the F is more than that value, then only the slipping will happen.
Yeah.
So
what we are trying to do is, see, slip happens. You see that vehicle speed is greater than wheel speed. Then only slip happens.
So that will happen only when the acceleration.
Your vehicle is moving forward. Say for example, this is 60. if wheel is, that means wheel you are applied brake. Because of this is 50. Then only the difference comes, no?
Exactly, sir. So this 50 will happen only when the road is slippery. Otherwise, it will not happen. That's my
Yeah,
question.
correct. You are correct.
So then that means the dry concrete road or dry
That's why you are getting maximum braking possible. Stopping distance is best dry condition.
so there will not be any wheel slippery in dry condition. That's my precise question is. It will be happening only when there is a water or maybe some spill of lubricant on the road.
Slip becomes zero if you lock the wheel over, no? Even dry road, if you stop the wheel rotation, automatically slip becomes 10%.
Okay. So you mean to say when I apply the brake and wind gets locked in that way, right, sir?
No. See, as wheel speed, you see, this is very simple. Wheel slip increases if the wheel speed start coming down. Vehicle speed, no. Vehicle has a speed, wheel also. Both, when there's no brake condition, both are equal.
Exactly, sir. So on concrete road, the wheel speed and vehicle speed will be similar. Same.
When you are not applying brake force, both are equal. You are allowing wheel, because both are rotate at the same speed. Vehicle speed, vehicle speed and wheel speed are same. Once you apply brake, you are applying brake only to the wheel, not to the body.
Right, sir.
Okay, then wheel speed start reducing. For example, this was 100. Both were 60-60 when vehicle was moving, both no brake. Now once you apply brake, this is start coming down. It becomes 59, 58, like that, because you are applying braking force. This is still free. Okay,
Yeah.
that means automatic slip increases. Slip from 0 it increases as the wheel speed is reducing. Slip increases.
Okay, sir. I could imagine now. Thank you.
Okay, thank you.
I'm sorry for this stupid
No.
question.
No. Good. Ask questions. It is not only clarifying; the others also get benefited. Others may not have asked questions; they also get clarified. If any student asks us, it will benefit to not only to everybody else. You are helping your friends also. They may not be asking, they may be little shy how to ask. Sometimes students don't ask what they think, what my classmate will think. He says you don't know even the simple things. Correct? Like that the people. But if you want to learn, even simplest thing you have to ask question, nothing wrong in it. It will help you also as well as others also. Thank you for asking question. You are asking good. You are asking a right question. Your questions are relevant. You are trying to make in fact you are interested in understanding things. Right? That is what your questions are very relevant. No question is simple as silly questions. All are best questions. That's what I always say. Thank you.
Sir, one more question.
Yeah.
Sir, this vehicle speed is calculated from wheel speed, sir, or how is vehicle speed calculated?
They put accelerometer. In the body, they put an accelerometer.
Okay.
In the center of the body, correct, they put on accelerometer. The accelerometer gives acceleration of the body, correct? If you do your integration, you will get the velocity.
Okay, thank you, sir.
So we know the other components of this one. There's ECU, there's a pump, valve, all those things. We saw this, correct? These things already we saw. The components, the pump, there are valves, pumps, storage units, motor, pressure fluid, all these things already we saw. The main thing is ECU receives information from wheel speed sensor, which in turn, if wheel loses traction, when wheel is get locked. When loses traction, when wheel is locked. That means the ECU sees that when wheel is about to get locked, wheel rotation comes to a lowest limit. But generally they don't come to, because it will come to lowest limit only when vehicles come. Because when 100 km speed vehicle is moving, you apply brake. You apply brake for only milliseconds. How many times I told you? 1200 times per minute. Correct? Within 1 second, you can do by 60.
Sir, one question, sir, for me. You told that the modulation happens, no, sir, for 10 milliseconds.
Here, this what I told. Within a second, 20 times. If I say the brake modulation, particularly ABS system, for XYZ company, I don't know name. I say X company, they say the ABS, the modulation frequency is 1200 times per minute.
Is it that is fixed for
The vehicle
any
manufacturer
system?
decides. Particular manufacturer decides what this one. It can be 2000, it can be 1000,
Okay.
or 2000, depends.
Okay, but it does not vary with vehicle speed, correct? So it is a fixed thing, irrespective of vehicle speed, it is constant.
That is fixed by the manufacturer. It is fixed.
Okay.
Modulating frequency is fixed. It
Okay, okay.
is not going to change. How much it will be, they decide. Higher the modulation frequency, smoother will be braking, no doubt. That's what one thing you can say. Yeah, I say that my modulation frequency is 20 hertz. 20 hertz means 20 times per second. Correct? Per 1200 times. Right? This is the X vehicle modulating frequency. And Y vehicle fellow says my modulation frequency is 40 hertz. What is it? 40 into 60. Correct? We know that 2400 times per minute. It apply brake releases. Now, if higher the braking modulation, the smoother will be the vehicle stopping. Jerk will not, driver, the passenger will not feel. Correct? It apply brake. You know, I told you, wheel was rotating, say, for example, 1000 RPM. I'm talking RPM. It will apply brake for how long? This is 1 divided by 20 seconds. If I say that 1200, the time T equal to 1 divided by 20, 50 milliseconds. Brake will be applied for 50 milliseconds. ABS will apply braking force for 50 milliseconds. Another 50 milliseconds release. Again, another 50 milliseconds. 50 milliseconds. Correct? Wheel was rotating 1000 RPM. Within 50 milliseconds, how much will this be braking? It will not reduce to 100 and all. It may reduce by few RPM. 1000 to maybe 990 RPM, 10 RPM or 995 RPM only. In 20 millisecond time. Next 20 millisecond, it will release the brake. So from 995, it would have gone to 998. Correct? Not 1000, because some energy gone. External energy you applied. From 998, it will come down to, for example, 990. After 50 milliseconds. Again, it will release it. It will go to 995. Like that, it does 1200 times. If you see that automatically within 1 minute, vehicle would have come to stop. The wheel rotation from 1000 RPM, it would have come to 0 RPM, because every time brake apply, few RPM, 2 RPM or 3 RPM reduced. 1200 apply, you have within 30 seconds. Correct? Within 30 seconds, vehicle would have come to stop without locking. If wheel is rotating 1200 times, 1000 RPM. If braking modulation is 120. Instead of that, if I say that other companies have 40 hertz is the braking, that means 2400 times per minute is applying per minute releasing. So how long it is going to apply brake? Instead of 50 milliseconds, it will apply 25 millisecond force, then release for 25 milliseconds. So from 1000 RPM, it would have come to 980 RPM only. 1 RPM would have reduced in 25 milliseconds. Again, brake is releasing. Correct? But vehicle speed will now go to 2000. It will be 999.5 RPM, 0.5 RPM. Will you see any difference? No. Correct? So it does 2400 within the your vehicle comes to stop gradually without the passenger driver seeing any sudden braking, smooth braking. But problem is, if I want to operate my hydraulic cylinder, brake, all the students should be able to work at 2400 times. Correct? You need special material, all these things. So the cost of the ABS will increase. If I want to do higher modulation, smoother braking if you want, you have to pay another 50,000 more. Correct? For brake system alone. That's why BMW, Rolls-Royce costs around. The braking system alone, you say it will be alone, will be to say 2 to 3 lakhs. They may be braking and doing from 2,400, 2,500, something like that. Okay, so that's already we know how it works. So this is what it is. We know that one of the important component of your brake, this ABS is wheel speed sensor. This wheel speed sensor is used for measuring vehicle speed also. Correct? If ABS is not there, you don't need the. Somebody was asking how the body speed, vehicle speed is measured. If ABS is not there, body speed is not immaterial. Wheel speed multiplied by number of rotation vehicle speed. But ABS only you need the slip, all those things. Right? So wheel speed is a very important sensor to measure vehicle speed And also for the ABS to measure the wheel slip. To measure the vehicle speed, they put a accelerometer in the body of the vehicle itself. Correct? That will give the actual vehicle body speed, that is called vehicle speed. Wheel speed, you are applying for wheel speed sensor. Generally, they use the inductive type wheel speed sensor. The signal coming from wheel will be like this, like the sinusoidal wave. Correct? The amplitude will be in the order of, for example, this amplitude will be maybe 100 millivolts. Correct? This amplitude. This is what coming from wheel speed sensor. But the wheel speed sensor signal should be given to ABS, which is a computer. So it requires not sine wave, it needs square pulses. The voltage level should be 0 to 5 volts. That is done by a special circuit. Right? So you can see that the wheel speed sensor signal given to one sensor that will convert into same number of pulses only, but only thing it made a square pulses, 5 volt pulses, and which will be given to ECU. Please note the ECU digital electronic circuit. It expects 0 to 5 volt signal, not millivolt signal. So the sensor signal should be amplified, converted to square wave. That is a special circuit is there. Special circuit will be there that will do that. So how will you do that? There are tooth wheel attached to your wheel, correct? So when the tooth rotates, it picks. For each tooth comes, the magnetic sensor gives one pulse. Correct? This is a gear. Tooth wheel, it may have 60. That means your wheel rotates one rotation, tire. This is attached to your tire. This will give 60 pulses. This 60 pulses will give. Correct? So the ECU count number of pulses per rotation. This one. Say for example, I am getting say 60,000 pulses. Correct? From my wheel speed sensor. But I know that when the wheel rotates this one, it gives 60 pulses. What is the wheel speed in this one? Divided by 60. Okay. I can say that this will become 1,000 rotations. Wheel is rotating 1,000 rotations per second. Per rotation, this is how it works. Okay. So wheel speed sensor signal will look like this. Correct? And that should be converted into square wave pulse, digital 0 to 5 volts pulses. Okay. This already, the next slide already we talked about basics of this one. Same thing only. Whatever we saw here, same thing I have put in. I got a better graph for you to understand. Somebody was asking vehicle how this one. In either free when wheel is this is free rolling wheel. That means slip is 0. Wheel slip is 0. You are not apply brake, correct? That time you can say that this is braking force. Braking force is 0. You are not apply brake, correct? But once you apply brake, the slip start increasing. And wheel speed is reducing. Vehicle speed remains, but wheel speed you try to stop the wheel and not the body. Brake is applied to wheel only. So wheel speed is reducing. So the slip increases. As the slip increases, the blue color one, you can see that this one is increasing. Braking force is increasing. Right? It goes to your peak value. I told you this is for particular road type. It may be asphalt road. I don't know. Right? This figure they have not mentioned. It may be particular road. The braking force increases from 0 to a maximum value. Maximum value happens here. Correct? When wheel slip is something around 15%. Please note that depending on tire, there are 1,000 or at least 100 to 200 tire manufacturers. Whether hard rubber, soft rubber, what is driver composite, the tire composite, rubber material composite, that what makes you have JK tire, you have the TVS tire, Chakra, correct? Bridgestone, Redstone, Apollo tire, correct? All these people, they never tell what is composition. Soft tire, hard tire, dry, all those things decides this frictional force between road and surface quality. Correct? If it is a soft tire, it will have better road grip. Correct? Because tire will get compressed by more patch area, but tire will wear quickly. But you will have better braking. Correct? Tire will, but hard tire, the surface contact will be less. Life will be better, but braking force, the friction will be less because contact patch is small. Correct? What is selling point? You say my tire comes for 50,000 kilometers. People will buy, but that tire will not give better braking because contact surface will be less. Maybe hard tire, correct? All these things, tire manufacturer won't tell. Their plus point only, the negative nobody says, correct? So recently I also got something, not with the tire, buying one water heater. Correct? I went to a shop to buy a water heater. My old water heater burned. This fellow said the 9,000 rupee, this has this rust-free body. Correct? We don't use steel, all those things. At the same water capacity, everything. I am electrical, I should have asked. Correct? I should have asked what is the heater capacity. I did not ask how many watts it consumed. Correct? They said, I asked them generally what is heating rate, both are good. I came and installed, open everything installed. But it takes half an hour to get heated. Then I finally found out they use around 100,000 watts heater. But previously I had another brand, same volume, all these things. It will heat up within 15 minutes. There it is 2,000 watt heater. Correct? So after when I asked, no sir, there is something, but you have to be very careful. I'm just giving an example. Like every product when you sell, they give positive, negative, say they won't tell. You have to be very, very careful. Okay. So I know that it is 6. We know that cornering, when there is slipping, the cornering force, you see that almost becomes 0. You cannot turn wheel. Locked wheel, correct? Steerability is lost because the lateral force becomes 0. You cannot steer the vehicle. So wheel should not get locked. At that time, you can see that still braking force is there, but it is less compared to the peak value. In locked wheel also, there is some wheel is in contact. No, it is slipping. Correct? Wheel is locked, so vehicle is sliding, but still there's a contact patch. But this is lesser compared to this. Correct? That's what I want to say. Another thing, somebody asked, is the vehicle speed. You can see vehicle speed is shown in blue color. Correct? The wheel speed is coming down because you are applying brake only to wheel. But when wheel speed is reduced, automatically vehicle speed also will come down. When wheel rotation is coming down, our body cannot alone go there. They are attached. But there's a difference, you can see that. Correct? This is a difference in any given moment. Any given moment, this is difference in speed. So this speed is measured using wheel speed is used. Wheel speed. This speed is measured using accelerometer attached to body of the vehicle. Vehicle speed. Correct? So then last one is I want to show is the hydraulic pressure applied to the ABS. ABS up to 0 pressure. It applies when you can see this one. When this valve is open, before valve, this force was 0 Newton. Once it was, fluid comes and applies pressure. The fluid from here, because they are waiting here, fluid is it open, fluid takes amount of time. Correct? In the pipe, maybe half-meter pipe or 2 feet pipe, the pressurized fluid should come. It takes some amount of time, no? That is what, because of that, the pressure builds. 0 before applying brake, then this increases. As it increases, the braking force increases. Correct? You can see that this and the braking force are same. But it takes amount of time. Then a constant pressure, because above all, the constant brake force is applied, then you relieve. So this is on period. A valve is on, C valve is closed. So then only the braking increases. Again, here's A valve is closed, C valve is open. So the fluid drains. Again, it happens. You will get the fluid pressure goes down. Again, it will remain 0. So not like this. Again, goes up like this. The braking fluid. Same thing, the braking also happens. Okay. So already we saw that. I'm not going to explain. I will tell this tomorrow or this one, little more about it. Right? Another 3 more slides next class tomorrow. We know that tomorrow, day after, we have classes. Last week, you missed some 2-3 classes. Tomorrow, day after, 5 to 6, we have classes. Both day and Friday also. We'll complete ABS tomorrow. Then we will talk about the autonomous vehicle, sensors for autonomous vehicle. Radar, LIDAR, all those things we'll talk. Okay. So thank you very much. Shall I close? All of you give your attendance as a chat measure now before leaving. Because I need attendance. Because I am supposed to enter your attendance, your grade sheet. How many? 80% attendance, 90% attendance, 10% attendance, I have to enter the grade sheet.
Yes, so far we are doing like this, sir. This time also we will do that.
Okay. Do it.
Okay.
Yeah. All of you give, please give.
Okay, sir.
Okay, sir. 5-3.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
You can go to the next class. I will copy the attendance, then I close the class.
Roshan Kumar. Sundar.
You can leave and go to the class, no issue.
Okay, thank you, sir.
Yeah, take care. See you tomorrow, 5 o'clock.
Okay.